Okay. So welcome everyone. First of all, I'm so excited to be kicking off today with a great discussion from our speakers, the AI Career Week. So this is not the first time, the second time this year we host the AI Career Week, where we bring different talks along with a career fair in 3 days. So today we have three talks from Dr. Mireille, from Jad, and Dr. Roy, where they will explain deeply how they are integrating AI into their company and how they are using it. So feel free to ask any question in the chat so you can benefit from the speakers. And I hope this will be an interesting talk for you. Before we start, so this is the talks that we have. Today we have the talk that is happening today. Tomorrow we have Women Shaping the Future of AI and Data. And on Thursday we have the Career Fair. Some of you might be joining it as company booth where you can connect and network with our community, and some other people could have already registered to network with companies. So if you're still looking to have a booth in our Career Fair, you can still do so. Sorry, let's mute. Please make sure you stay muted. Okay, awesome. So this is the panel discussion that is also happening tomorrow. So I hope you will be able to join. It will be it will have some insights from also experts in the field who are working in AI, data, and data science, where they will tell us more about their struggle, their challenges, and how they entered the field. So I hope to see you tomorrow also. So one more thing that we launched earlier this year, like maybe a month ago, is our Made By, if you want, a branch in Zaka, where we have an AI implementation branch under Zaka, where we implement AI solutions for companies, and we have a portfolio that we're showcasing it on our website. So do check the website. I can share it in the chat. It's interesting to also see applications of AI, and we're so excited to bring more and more projects into Made By. So I hope you'll check the website and give us some feedback. So now we will be starting, each company or each speaker will have around 15 to 20 minutes to discuss their solution. We will start with Dr. Mireille. She's an AI solution expert at Apgar. I will stop sharing, so Dr. Mireille, you can share your screen. I think you already have access. Please let me know if you face any problem.
Yes, I can.
Okay, so I think try to talk now to check if we have an echo.
I think it should be fixed.
It's great. It's great. So just a quick introduction, Dr. Mireille Makari is a solution expert in the Advanced Analytics and AI department at Apgar, and she's designing and implementing AI and Gen AI solutions. And she's also a lecturer at the American University of Beirut and an advisory board member of the Technology Transfer Office at USAC. I'll keep maybe the introduction for Mireille to go deep into her experience, but what she will be presenting is augmented data management and to discover more a transformation journey powered by Gen AI from extraction to consumption at Apgar. So Mireille, I'll keep it for you to start.
Thank you so much, Larissa, for the introduction, and thank you for having me. It's a great pleasure to represent Apgar today. So we will be talking a bit more not on how AI is being integrated at Apgar, but we thought it would be interesting actually to share with you the stories from our customers and the type of solutions that we actually provide to our customers in the AI field. So I will just take a couple of minutes to introduce who we are as an Apgar group, and then I will delve into the solutions that we offer, which are related to augmented data management and CogniOps for AI-driven operations. So if we simply want to say who is Apgar, we would say that we are data experts. We are a leading data advisory company. We have support for data advisory services for small, large companies in Europe, Middle East, North and South America. And we value commitment, partnership, excellence, and ethic. So when we say commitment, because we're committed to our clients, we try to deliver the best services we can. And because they trust us, this leads to a partnership relationship with them, which lasts right from the beginning. So our company started in 2013, and we still have the same customers. We are even growing, but we maintained a good relationship with them. So we try to enforce a partnership relationship rather than simply being supplier and customer relation. We always seek excellence. That's why we have the best talents. We try to always upskill our knowledge and make sure that we are experts in data field. We make sure that whatever we deliver, we are bound by ethic, the social responsibility, financial responsibility, and even the responsibility towards the community. So we started right in 2013. The main quarter was in France, but now we are almost everywhere in the world. We have more than 120 customers worldwide. One of our CEOs is Lebanese, Mr. Ala Hablus. And we have more than 200 data advisors. And you could see that we have a bunch of them here in the Middle East, Abgar Lebanon, supporting us today. So thank you, Abgarian, for the support. The main pillar that we offer are revolving around data advisory, data enablement, and data acceleration, meaning that we provide advisory services in data literacy, data governance, and AI catalyst. So we help our customers figure out the use cases that they could actually build. Sometimes we have data, we don't know how to leverage it or what to do with it. So we are able to walk beside our customer to help them figure it out. Then we move to data enablement where we actually build solutions. So we build master data management solutions, metadata management, AI, augmented data management, and AI-driven operations, among others. When we found that actually most of our customers have some similarities in their offerings, we configured solutions that could be automatically installed for the customers. This is what we have in the data acceleration pillar. So our excellence is recognized by Gartner. We were named one of the top 18 major master data management for external services, and we have also been recognized as the best vendor for the AI and data analytics by Gartner, who's a well-known research company and a benchmark for data management services. We have a variety of customers in different industries. So as we can see, we have customers in manufacturing, in pharma, in healthcare, in food, in insurance and finance, transport, supply chain, and other sectors. You might recognize some of the names like L'Oreal, Novartis, AXA, DHL. So these are all customers which we have a long partnership with. Excuse me, was someone asking a question?
I think it was by mistake, so
okay. No issue. So basically, this is a quick introduction of who we are. So all we do is related to data. And we know that data is important when we want to talk about artificial intelligence. So the first topic that I'm going to discuss is the augmented data management. And because I like telling stories a lot, so today I will be telling you the story of how we could actually transform the data. What would be this journey of transformation from extraction to consumption? And in order to be able to focus more on what we mean by that extraction to consumption, I will just give some context of the master data that we work with. So when we say master data, this is really a reference data that is a single source of truth that we need it to be available, especially when organizations actually have multiple systems that they need to use so they can support their businesses, their operations. So the master data management will actually log the information about important entities like customers, products, suppliers. And there we have a lot of challenges when we have some manual work that needs to be done. So we see here an example of a master data record, which is a customer, for example, where we have the name of the customer, their middle name, and their address. So when it comes from different systems, then we might have an issue when we have duplications that we need to identify. And it starts when we actually want to fill this data in the first place. So we need to have a single source of truth. This is what we refer to as master data management. Now, to start with this journey, why do we need augmented data management and how we can leverage AI in this domain? So Sarah is a very good employee. She's very hardworking, but she has a lot of work to do, a lot of manual, repetitive tasks to do. And this is keeping her from actually focusing on strategy, on doing things faster, on more efficiency, because she spends most of her time doing manual work. So the journey that we are going to take is actually to help her do things faster by leveraging AI and therefore becoming more efficient and focusing on more important tasks. So what we offer in the augmented data management starts right from the beginning when Sarah needs to create information. So to input, let's say, data related to customers, related to suppliers, to feed those systems, she has to go through the documents. If we're talking about, let's say, customer, I have to look at customer documents, their name, their address, sometimes the invoices, sometimes other documents that could be related to that customer. We have to read them manually and then accordingly extract the information and inputting it. So this takes time. That's why what we can help with leveraging AI and more specifically generative AI starts right from the beginning by the data collection. So we need to collect the data. This is the unstructured data, which is the set of documents from which we could actually extract information. And we proceed by using that large language model, fine-tuned model. It could be also leveraging some examples. We get the master data record creation by simply identifying what could be the attributes that we actually need from those documents in order to input the information into our master data management. So once we have that data extraction, you can imagine that sometimes we might have similar documents or even customers that have a little difference in their addresses, in their middle name. Instead of saying Robert Smith, I could have Bob Smith. Instead of saying one, I'm writing actually the word one. So they are kind of the same, but with a small difference. That's why we need to identify what we call entities that are similar. So we leverage AI, traditional AI techniques to do AI entity matching. So we recognize potential candidates that could be considered as the same record, as the same master data. All of these are actually in the creation, in the preparation, and in the curation of the data. We are making it ready. Ready for what? To be consumed. If it is found in the master data management, it could serve later on for the business operations. But what is more important, if Sarah wants to actually search for information, it would be much easier if she can ask a question and let's say in natural language, whether it is in English, in French, and automatically an interface or a chatbot could assist her in answering the questions right from the documents without having to put much effort. So we have knowledge assistant, conversational chatbot that will leverage what we call retrieval augmented generation to be able to look for information inside those documents and answer her need without having to go and manually search inside those documents. An additional layer of analysis on data could be with the data analyst that we provide. This is also a conversational chatbot, but now the task is going to be to translate between natural language and SQL statements. So if Sarah wants to have some reports, if she wants to see an information that is coming from multiple tables, she might have to ask a technical expert to write the query or to implement a report. Instead, she can communicate, she can ask a question in natural language, and leveraging Gen AI, we are able to form that SQL question, to execute it, and then to get the response along with a visualization that could be more meaningful to business users in order to analyze the data and then form or do better decisions. So if we start from creation and we end with consumption, therefore leveraging AI today, this will reduce the manual work, reduce the repetitive task. And as we can see, then we will have the outcome where we could actually have a happy employee because Sarah would be happier, she's more efficient, and she can actually focus on some better strategy work, on some more complex tasks that were before being consumed by repetitive tasks. So this augmented data management, if I want to show it in action, we have a set of documents that you see here. So we have a set, for example, of CV, of job offers that we can view in terms of documents. They have different formats, they have different layouts. And when we want to extract it into an actual structured information, so simply by leveraging generative AI, we could see that this document was actually turned into a structured record where we have the name that was automatically extracted, the email, the phone number, the address, whether it was found or not, the list of skills, and even some additional attributes that were automatically identified within the document. So this is not specific to a domain. This is not specific to a use case. It could be adapted to any type of documents or domains that we need to process. For the AI entity matching that I was mentioning, if we look at the different systems that we actually have today, it could be ERP, SCM, CRM, and business intelligence or data warehouse applications. We see that we might have different records coming from different sources, but eventually they could form the same record before they are being consolidated into MDM. So the entity matching will recognize these entities as being similar by leveraging, whether we're using fuzzy matching, but sometimes it's not enough. So we leverage AI. We're talking about clustering. We're talking about vector similarities, semantic similarities, in order to be able to know whether these could mean the same record or not. For the conversational bots, so this is the knowledge assistant that we are using. So the user here can come and provide the input in natural language, and we see that the extraction comes from the knowledge base that was actually provided. We know how important human feedback is because this will help us enhance the model and being able to do better, understand where it fails, because it's a work in progress. We are actually generating the information. We are looking for similarities in the data, and we always need to enhance the model in order to do better. So this is from the knowledge base. We're going to see in a bit what could be the challenges that we actually face with such type of conversational bots. With the data analyst that we mentioned, it was able to actually ask a question. So what is the total sales value for product company? It will show the answer, and then it will present a chart or a visualization that will report the answers. So with this, what we're trying to have is a human interaction with the system, leveraging AI so we could make things easier, and the customers will actually have less the need to be experts in specific domains, but rather than democratizing the access to their data in a fast manner. Of course, these solutions, whatever is the industry that we're working with, come with a bunch of challenges. So if we want to address these challenges, we start by the technology, the models, and the frameworks we need to use. Are we going to use cloud services? And if we say we're going to use the cloud, is it Microsoft Azure, GCP, AWS? What kind of frameworks for generative AI would like to use? If we're modeling the natural language, what type of models we need to use? Is it OpenAI, something commercial? Is it something that is open source like Llama or Mistral? How do we make the trade-off between performance and between the actual accuracy that we need? And then the next challenge, we have identified the technology models, the volume of data, and the type of data. Because the volume, usually when we're discussing organization types or specific industries, we might have a high volume of documents that we need to process. If we're talking about structured databases, we might have data models that consists of hundreds of tables. Each table has hundreds of columns. So how to identify correctly which tables to use in order to retrieve the information from. The type of data we want it to be more often multimodal. So not just dealing with text, but also processing images, being able to read the image, being able to generate an image as well as a response. So this definitely leads to challenges in cost, because whatever is the framework and the volume, we will have costs that we need to account for. And the more we use the large language models, especially when we go through proprietary APIs, we will have to consider a high cost because it charges based on tokens. And therefore, the trade-off between having an optimal result and actually having something that is cost effective when we're talking about companies with hundreds of thousands of users or even with thousands of users, this becomes an issue. Another challenge that comes not just with generative AI, but also with all type of AI models or projects, this is bias, ethics, and fairness. So we want to make sure we have appropriate content filtering. We want to make sure that our conversational bots, for example, are not really biased towards specific type of answers. And fairness in order to provide balance between the answers that we actually get. The most famous issue when it comes to generative AI, we know this is hallucinations. So we reduce hallucinations when we provide input that is documents, that is private data, because we can focus on retrieving information coming from our data source, from our data that we have fed or that we have used as a knowledge base. But this cannot be eliminated unless we say that we do not want to have any external answer or any external source that is being used. The languages, because the more personalization we actually give, users would like to communicate with these conversational chatbots in their native language. So if we're talking about Middle East or Gulf customers, they would like to interact with it in Arabic. When we're talking about French customers, they would like to interact in French, in Spanish, and Portuguese. So the ability to use different languages and still being able to answer the questions correctly, this is a very high challenge to overcome. Regulations and compliance, when we deal with healthcare, when we deal with HR informations, they are all subject to regulations and compliances like GDPR, like HIPAA. And because we work with this type of customers, this is a very important concern that we need to address. So we make sure that the solutions we provide are actually abiding by the compliance and regulations that are specified by the country where we're actually operating. And finally, the most tricky part is explainability. Fine, we got the result, we got the answer. How do we interpret it? How do we know that we actually got the right answer, or at least get the language model to explain how it obtained that result? So the reasoning or the chain of thought that led to getting the following information. So this is, in general, the augmented data management, because the actual challenges or difficulties are the same, whether we're using natural language processing and augmented data management, or whether we're working in manufacturing or supply chain. We also leverage AI for business operations. So CogniOps is one of our offerings that help us focus on driving business operations in manufacturing for industries in order to be able to help them. For example, we see here the demand forecast. So if we're talking about food and beverage, let's say at a restaurant, they want to forecast their demand in terms of menu items, how many menu items they are going to have per day, per week, and eventually per month in order to increase their sales. We could have, based on the demand forecast, accordingly start their capacity planning and production. So in manufacturing, they want to use specific machines. How long should they use it? How many orders can that machine actually produce? So we provide scheduling optimization and capacity planning for it. And we provide improved operational efficiency and reduced downtime by doing a predictive analytics. How long can I still operate my machine before it actually defaults or before it actually stops running? And this will definitely provide better efficiency. Finally, to reduce the sales cost and to increase them, we offer personalized recommendations. So what would be the next best offer for our customers? By doing collaborative filtering, by doing recommendation systems based on what exists in the sale historic data. So just a quick overview of the AI solution for business operation. This is for demand forecast. So as we can see, this shows the trends, a time series analysis over a period of time to show per menu item, for example, what was the consumption over the year. And then this will allow to find the trend per day, to find the trend per week, to find the trend per year. And in case some event happened because it was a holiday, let's say, or because it was a weekend, or because we had some event going on nearby that actual restaurant. Yeah. We also have the demand forecast, which identifies outliers, what happened on that day, so we could actually get that increase in sales or in revenue. And this is finally how we predict or we forecast the demand based on different regressors. And finally, for the schedules optimization and planning, this is an example where we tune the parameter. This is an example really from manufacturing. So we identified the parameters and we identified the demand forecast that should be made by X time. And therefore we generated a plan to say who should be working on what machines should be operating, and accordingly being able to accommodate for our resources. So that was a quick journey throughout what ABGAR does in terms of AI solutions in augmented data management and in CogniOps. So I hope this was insightful and gave you some ideas about how we can leverage data, because we always know that we need to make the best use of our data, especially when it comes to AI, for us, for the ecosystem, and for a better world. Thank you, everyone. I will try to answer the questions now.
So thank you so much, Mireille. I think, do you mind if we take the questions at the end? I tagged you so we don't forget. So we,
Of course.
okay. So maybe we finish all the presentation and then we take the questions one by one. Okay, thank you so much. It was insightful, but for the sake of time, we'll continue with the next presentation. Please ask your questions now to ensure that those are for Mireille in the chat, and we will definitely answer them. Okay, so we will go to the next presentation. Jad, are you with us? So Jad is the CTO at Lockseed. So you'll be able to share your screen. Am I sharing my screen? Can you see it? Okay. So Jad is the CTO at Lockseed, and he will show us more how do they integrate AI into robotics and computer vision, specifically in agriculture. So I hope this will be insightful for you. And as I mentioned, please do ask your questions in the chat for Dr. Mireille, and she will be able to answer at the end.
Okay. Do you see my screen?
Yes, clearly. Go ahead.
Okay, perfect. So I'm not sure how much you know about agriculture and the use of AI with agriculture, but if you do the research, well, lately, especially AgTech has been a very big, let's say, emerging market due to the overpopulation, due to the lack of food, due to climate change. So a lot of actually governments are paying a lot of money right now to be able to have greener agriculture in general. And actually, the idea started way back I would say around 2020. So we were a very small team. So we have the founders, which are Guadaluna Shaer and Georgie Kassab, and me, the CTO of Lockseed Robotics. And we started as a very small team with we were actually studying at the Lebanese American University as mechanical engineers, and then slowly the company got bigger with the more funding. So we started with Agritech, which is an accelerator program in Lebanon, and now Lockseed has moved to the Netherlands, specifically in Venlo, to continue the startup there. So the idea started because, we noticed that there are crazy amount of losses that are happening, especially when it comes to in the agricultural world due to wheat plants. So these plants, in the US and Canada, it is estimated that $43 billion of losses are due to the presence of wheat, or these plants that actually harm the crops that we need. And so the problem is that these wheat plants, we can compare them to, it's like cancer, because they actually need a lot of nutrients, they need a lot of water, and they steal a lot of these important nutrients from the crops that we actually want. And ever until now, mostly the solution is based around either manual labor or herbicides. So the problem with manual labor is that there's a lot of shortage in terms of work opportunities. It's very expensive and it's very unreliable because it's very time consuming and you need a long time to actually remove the weed over very big fields. As for herbicides, I'm sure you all know that herbicides are very bad for the soil and they can be very poisonous. And also you may, for example, kill a lot of your own crops because of the use of herbicides. So we were brainstorming, and this is how we came up with the idea of Lockseed Robotics. So the thing is that usually until now, weeding in general, again with manual labor, costs around 2,500 euros per hectare. And if we're talking about organic farming, it can go up to 4,000. And this is not something that is very sustainable. And now that the AI is emerging, the field of robotics is emerging, we figured why not combine those two and try to make something that is more autonomous, something that can be faster. And so this is where the idea of laser weeding came. So basically the idea behind laser weeding is to actually point a very powerful laser at the plants, or the wheat plants, or the plants that we don't want, and then kill it directly. And so a lot of research has been around that topic, of course, manual research. So they would manually point the powerful laser on the wheat itself, and they would see how it dies. So the goal behind Lockseed is to automate this idea and and make it much cheaper for the farmer in the long run than, for example, using manual labor. And from the research, you can see laser weeding can yield up to 50% savings for organic farmers. You have 30% higher yield in terms of crops, and of course, you have better crop quality in general. And so the idea behind this is to have an apparatus, let's say, with a camera pointed down on the ground and a vehicle that moves around the field. And the goal is to have an AI model. So this is where we integrate the AI component, an AI model that can detect the actual growth center of the wheat plants, and then using a control system for the high-powered laser to be able to go over those weeds that we don't want and kill them accordingly. And I'm going to show you a small example now of what we've achieved so far. And so I'm going to first show you part of the AI model and how it's working, and then I'm going to show you the laser component and you'd see how the actual laser is burning the weeds. So in this video you can see, this is when we were doing our small test videos. We were testing our AI model, and as you can see, so these are the wheat plants. And in the center of the wheat plants, this is where the growth center is, and this is what we need to actually kill, okay, to be able to kill the whole leaf. And so you can see, so this is actually our AI model working in action. So the idea behind our model is to make it as cost effective as possible without actually with good accuracy. And the thing is that, now with NVIDIA releasing a lot of embedded systems like the Jetson platform, we figured we can actually make the AI run online, so directly on the field, without the need for very expensive servers or online connectivity, because especially when you are working with field vehicles, then it's not a really good idea to stay connected on the internet, because when you are working with remote fields, then you don't really have good connectivity out there. And so the whole point was to optimize our model as much as possible while preserving accuracy. So it's a trade-off. And of course, we had to do a lot of studies to make sure that the trade-off, so accuracy is there and also efficiency. So after the AI, so while the AI is actually detecting the growth center of the weeds, we set up our laser system with which it is controlled. And then you can see here, so this is a small demo of our laser control system and how it's burning the weed. So here you can see, for example, we were doing manual tests here, and they click on the weed that they want to kill, and you can see this is what we get at the end. So basically, the whole apparatus is a combination of those two, and everything is run locally on the Jetson or on the embedded platform itself. We had to do a lot of data acquisition, of course. So in Lebanon, actually, we got in contact with so many farmers to get a lot of data. We also had to label those data, so we had to collaborate with other labeling companies to be able to label that data for us. And actually, these tests are done in the Netherlands. Keep in mind that while, for example, this video is in the Netherlands, all the training data was actually used from Lebanon. And you see how easy, for example, our AI model is able to generalize over other types of weed, because at the end of the day, you will have very different weed types, very different shapes. So our approach was to simplify the problem in order to get accurate and good results. I'm going to show you, this is another example of so this is some of the data that we've gathered in Lebanon, actually. And you can see that the AI model is not only able to infer where the growth center is, but you see based on the size of the axis, you can also infer how big the weed itself is. Because also when you're weeding, you would need actually to know what to prioritize. Because, for example, a small weed is much easier to kill than a very big one. And so using that extra information, we can also use that to make it even more efficient, okay? So we have a lot of competition in the market. Again, like I said, it's a very competitive market at the moment. It's an emerging market. So you have something called laser weeding, electrical weeding, spot spraying, and mechanical weeding. So basically, laser weeding is what we use, what our technology uses. You have electrical weeding, which actually, let's say, gives a very high voltage to the plants and also kills the weed. Spot spraying, they use herbicides, but in certain spots, also coupled with an AI model. And finally, you have mechanical weeding. So one of the, let's say, pros of using laser weeding is one, it's very precise because you're just using a very small laser pointer. It's much faster. Of course, this depends on what you are using to actually control your lasers. External expenses are reduced, especially because you will not need any herbicides. Even in terms of moving parts, they're not as, for example, as many as mechanical weeding. And also, well, it's organic. Also compared to spot spraying, they use herbicides, but in our case, we don't have to. So we also, inside the laser weeding market, we have different competitors. So, for example, Weedbot, Carbon Robotics, Terra Robotics. So these either use a laser weeding or a combination of electrical weeding and laser weeding. But the thing is that what we aim for is to make it as affordable as possible. Okay, so for example, in our case, we know that we have to directly hit the growth center of the weed instead of hitting, for example, all the weed. However, other companies such as Weedbot, what they have to do is they would have to actually try to identify the whole weed itself and then try to kill it. So stride over the weed, which will take much longer because in our case, we're just hitting the center. Carbon Robotics, they have a different approach. However, their AI is huge and they need a lot of training data to be able to train theirs, which doesn't really make it, let's say, efficient because first, it's very time consuming to actually get data and to label data. And second, because the thing is that when you are using, for example, big machinery to actually run your AI on, then this will need power. And this is not really, this reduces the portability of the device itself. So this is more or less an idea of what we're doing right now at Luxeed. So actually this week we had a couple of experiments that went very well. And we're hoping soon to actually finalize, let's say, a product that can be sold. And this is all thanks to our team. So you have the founders, Guadaluna Shair, Georgie Kassab, me as the CTO, and the very hardworking team members of Luxeed. And yeah, so this is basically it. One thing is that, of course, at Luxeed, we're always looking to make our team bigger, to have more people working with us. So whether for internships or job opportunities, you can always contact us, and then we would get back to you if any of you is interested in this field, in the field of robotics and computer vision and agri-tech in general. Thank you very much.
Thank you, Jad. Thank you for the insights, and we'll definitely see you also in the career fair. So now we will go to the last presentation. If you have questions for Jad, please ask them in the chat, then we will be taking them. We have also Dr. Jad with us, Dr. Roy with us. Are you still here? Let me check if I can see you. So Dr. Roy Laban is from Previse AI. And Previse AI is a team of experienced computer scientists building artificial intelligence solution to optimize enterprise operation. They are based in Toronto. He is the CEO of Previse AI, and he has more than 25 years of industry experience delivering advanced technology solution for enterprise of all sizes across multiple industries. So please, Dr. Roy, if you can share your screen, and the floor is yours. And then we
Thank you, Larissa, for the introduction. I'm going to share my screen. Please let me know when you can see it.
Yeah, of
and
course.
Hello, everybody. It's a pleasure to be here.
Pleasure to have you. I think it's in the morning now for you.
It's in the morning. Yes, it's 11 a.m. actually. So yeah, it's all good.
Okay, great. So we can see you and hear you clearly. We still have...
Okay. Let me just bring up my screen. It'll take me just one second.
Take your time. We will have to stay 10 more minutes and we will hopefully be done. So sorry for keeping you waiting more than the time that is needed.
Please let me know if you can see it.
Yes, we can see it. Can you go full screen?
I'm trying to do that now. Did
Yes,
it work?
It worked. Go ahead.
Perfect. Thank you. So hello, everybody. My name is Roy, and I'm the CEO of Previse AI. We build advanced technology solutions for enterprises of different sizes. And recently, we've been focusing a lot on developing artificial intelligence enterprise environments, mainly in North America. Today, what I'm going to be talking about is our implementations for medium to large enterprises in terms of how to integrate large language models within the enterprise. So we're not developing just chatbots, we're developing actual productivity improvements that integrate along the workflows of enterprise software. So our Previse AI system, we leverage large language models to offer natural language AI-enabled solutions for enterprises. We have AI-enabled workflows, we improve productivity, and the integration is basically seamless within the client environment. We develop also knowledge management portals that use natural language AI, and we use custom fine-tuned LLMs that we custom fine-tune them ourselves, depending on the target use. This offers smarter searches, faster, more accurate results. We get summaries and extractions with references and so on. And definitely what we do is we offer this solution in a secure, private, and local modality, either self-hosted on a private cloud or on premises for our clients, because most of our clients are have IP that they want to protect. A lot of them are research entities or regulated entities that do not want their intellectual property to go online. So all of the work that we do is either on-premise or in private cloud environments, where we host their data, our models, and they run completely away from the public internet. What I'm going to do today is, first, let's talk about the features we integrate. We have our custom fine-tuned open source models. We have a team that customizes some of the models for our clients. We do some of our own fine-tuning, and we are using larger models for implementation. Our RAG platform is fully customizable. We offer an API platform for chat generation, completion, and ingestion. And we also offer standalone user interface implementations for knowledge management or knowledge-based querying or portals. And we also support, of course, tools and functions for enterprises. The main two that we've been asked about really is web searches and web scraping. The rest, not so much recently. And as we said, security and privacy, all this resides within private cloud environments or on-premise. I just want to go through the different use cases that we have implemented. One of the main use cases that we've been asked for is information extraction. So we're able to run our models and using basic RAG with our model, extract information and integrate this functionality not only through a web interface, but through actual client enterprise software interfaces. I'm not able to share any of that here because we are under NDAs, not to share even the names of our clients, because they are research entities that do not want their names to be known that they're using this technology for some reason. But this is one of the uses. They want to be able to upload reports or upload documents and extract information from them. Another use case is they want to have hybrid or generic chatbot assistants that allow them to search through their documents to look for suppliers that are good or suppliers that are bad, so they can blacklist them. They want to also look at suppliers that are able to deliver certain types of information or certain locations where they can serve certain locations. A third use case is for sure summarization. And for summarization, this is one of the main use cases we've seen with different clients, where they want to add this functionality as part of their interfaces. They attach documents they're working with, they select which documents they want to summarize, and they just click on a button. It does the first iteration of summarization, for example, for them. And then once that is done, they're able to iterate with the system interactively on screen until they arrive at a version of the summary that they really like. And then that gets inserted into a record in the database where the actual files are attached. And this saves a lot of time for them. A lot of the reports they have are in the tens or hundreds of pages. So this serves to just give them a brief summary of the documents they have, and they're able to potentially save hours per day. Instead of reading all the reports and summarizing them, they just resort to this. Now, checking the quality of this, they have a quality assurance system in place, and we are actually using a multi-step process for this, and we're using quite a large language model that we fine-tuned for this specifically. So this has been working really well with us. Document compare. Excuse me? A document comparison, that's another use case we've been asked for. where we are able to load multiple documents into the system and compare them. What I'm doing here is I'm giving a generic example of a document comparison that we did for a proof of concept for one of our clients. But the thinking here is also similar to the previous use case. We're able to put multiple documents, select them through the user interface of the client software, and they can do a document comparison and upload the comparison into a location within their database and use it later on or immediately to compare versions of documents and also produce discrepancy reports between different versions of documents. Another use case we've been asked for is sentiment analysis. Some clients receive a lot of feedback or questions and answers on their implementations from their users or from their actual development teams. And we wanted to allow them to have automated sentiment analysis. Instead of them having to go through the different comments or feedback they receive, they're able to iterate through the different comments they have and build reports describing the sentiment of every document or every comment they've received. And this has been quite interesting. This is actually a use case that's in development and delivery right now. It should go live with one of our clients within the coming few weeks. Context creation. This is another use case we're working with where our clients are able to create content from the LLM that we're hosting for them, automatically with no RAG input. This is from scratch. And this is here an example where they wanted to create a request for proposal. And the request for proposal, I've changed the name of the company, of course, in the example here on the left, but they were able to create a request for proposals very, very quickly in a couple of minutes and use it as a first draft and iterate on it until they had a good draft that they took away and used. And what's next? We're working on vision right now. This is an example output of one of our vision models. We gave it a chart describing the comparison between GPT and Lava, because Lava is a vision model. And we decided that our vision model should tell us what's in the chart. And apparently it did a not so bad job, but this is still a work in progress. And we hope to have a version that is enterprise ready by March or April of this vision model integrated within one of our clients' applications. Another thing we're working on right now is Arabic RAG. And we have faced some challenges with Arabic RAG because of the tokenization and ingestion of Arabic documents. Different documents are encoded differently, and there isn't much embeddings models on the market that do a good job. So we had to do some custom work on some of the embeddings models and some of the tokenization algorithms, actually, to get this working well. This is one of our examples, and we have made a bit more progress than this example. This is an older example. This is maybe 8 weeks old, but we have made some progress, and we are now ready to go into the Middle East market with Arabic RAG, both in a standalone version where we're able to offer this as a portal or within enterprise software. And I think that's all I had for today. A very quick presentation, actually.
Awesome.
Trying to keep on time.
Awesome. It helps us stay on time. So
Of
if you
course.
have any question for Dr. Roy, please ask because he has to leave now. Otherwise, thank you so much for the 3 speakers. It was really insightful to hear from all of you and to understand maybe different application in different industry, which is something also interesting. So if you have any question for Dr. Roy, ask them now, and then we can take the questions. Thank you so much.
Larissa, I have to drop off,
Don't
but I will
worry.
leave my email in the chat. I really apologize, but I really have to
No
drop off.
worries.
They're waiting for me on another call. I will leave my email in the chat. Please email me any questions you may have, and I'll answer directly. Thank you so much again for hosting this. And I'm glad to see such a big number attending these events.
Thank you, Dr. Roy.
Thank you.
Hope
Thank you, Dr. Roy. Very
Bye.
insightful.
So let's take the questions in the chat. I saw, Dr. Miray, you were answering some of the questions, but let me start with the Laith question. It was the first. So can you read it or I read it? What techniques are used to resolve conflicts when multiple data sources have contradictory records for the same entity?
You can hear me?
Yes.
Let me
Yes.
just use the speaker. Sorry, you can hear me, right?
Yes, clearly.
Okay, so basically, because we operate using master data management frameworks, they usually have embedded tools which is called match and merge. And when we say match and merge, this is basically looking at the different conflicting entities to give the user the ability to choose what to do, whether they want to match it, in case it was a match, whether they want to merge it into one master data record, so taking the fields that exist from multiple records and put it into one. So human validation is quite important. The AI is able to identify that this is a match up to a specific confidence score that we have. Let's say they are matching up to 90%, 95%, even sometimes we get to 99% or 100 or 98%. But even with that cases, it might not be a match because it depends really on the industry, on the type of the data that we're trying to look at and to find whether they are similar or not. So human input in our case is really important, but we're making it easier for the user rather than looking at random records. They only have small clusters where they could actually validate the confidence score and determine what to do. So it's a merge or simply keep them as separate records. This is for the first question. The second, the scalability of the entity matching process, we're really talking sometimes up to 1 million records to match. So you have to apply a kind of a blocking technique first in order to reduce the number of records that you need to match against. So because if you're trying to match all the records together, that would be a quadratic problem. So you're talking about 10 to power 12, which will never finish processing. It will take a long time. So we try to block to reduce the number of records that we're trying to match, and accordingly, we can start the similarity matching between them. And finally, in cases where the AI misinterprets context during data extraction, are there built-in feedback loops to refine its understanding dynamically? At the moment, when integrated with MDM, it's the user who's validating. It is launching automatically a workflow, but we are now working on this automatic feedback loop where we send the request again to the LLM and asking it for the missing field or for the fields that the validator actually said that these are incorrect or that we still need to do a better job in extraction. So it is in the pipeline of implementation currently. I don't know if this answers your questions, Laith.
I hope so. It was detailed enough. So maybe we'll go to the next question. Okay, you answered this one, you answered this one. Jad, if you're here also, we have a couple of questions for you.
Yeah, sure.
I'm checking Mirai questions. Mirai, can you still see any question that you didn't answer? Because I see
Jinan maybe is asking me if I'm using the locality sensitive hashing for the task. It could work in some specific cases, but it becomes really hard in case you're using vector embeddings because it doesn't work well in some cases. So what we try to block according is based on some specific attributes, or we try to apply, let's say, a first step of fuzzy matching, let's say, and then accordingly we can reduce the numbers. Sometimes if we're dealing with customer data, they might have specific groups or categories for the data. Therefore, you can say, I want to match categories, the records belonging to a specific category or to a specific type of material that we have before we start the matching between them.
Okay, cool. Thank you, Dr. Mirai, so much for all the deep insights. I also saw your answers in the chat. If you still have questions, do drop them before we close. And Jad, you can see some of the questions that you didn't answer.
Yeah. I'm gonna actually, there are some questions who repeat themselves, so I'm gonna go over. So I will start from the questions that I haven't answered yet. I think it's better to say it
Yeah,
rather
go
than
ahead.
writing. So I
We have
see
Mark.
from.
Are you using data from different segment of the electromagnetic spectrum to enhance the accuracy of your data point by chance?
Well, like multispectral imaging. Is this what you mean,
Mark, are you still?
Yes.
Mark?
Hello, how are you?
Yes. So, well, personally, I've worked with multispectral imaging before, and I think the problem with multispectral imaging is that you will get a lot of data points that can be overwhelming to the actual AI model. And the problem is that we had so many. So at some point, I was working on a different project, and the problem is that the environment can affect those data points and can confuse the network. And so we decided to stay with the very basic thing, which is RGB. And I think RGB is much more than enough to detect these kind of things, because you have the color, so the contrast between the background and the leaf itself, which is very clear. And so the important idea of the network is to teach it on how to extract the features, or the, let's say, the shapes of the leaves, and where they connect together. And this can be easily done just by using an RGB sensor. Okay.
Cool, thanks, Jad. So we have a question from Razan. I know an OS for robotic called ROS. What difference does it have from AI models, and is one of these technologies better than the others?
Okay, so basically, when we talk about ROS, so the robot operating system, it's mostly a general operating system that is used for robotic deployment. And so let's imagine, I don't know, let's imagine you have Linux or Windows or an operating system in general, and on that operating system, you can run, for example, Chrome in one tab, and then Microsoft Word or whatever in another window. And more or less, robot operating system works the same way. And so when it comes to AI, your AI will be a program inside that operating system. And the whole point of using ROS is to, let's say, because when you want to run two tasks in parallel, then you need to multi-thread, you need to do a lot of stuff behind the curtains, and this might take a long time to code. And so let's say ROS is just a integrated solution for that. Okay.
Yeah.
And also, are the types of cameras and the computer vision models important in this product? Yes. Well, first of all, we need clarity. So as much contrast as we could get would be better. So to make it easier for the network to observe the differences between background and weed plant. And for the cameras, since we need not only to detect it like on the image itself, we also need to hit the weed itself. So we need sensors that also give us depth information or 3D spatial information to be able to send the laser to that specific point in space. Then there's light. No.
That's like.
Just
What
a
programs are you
second.
using? Are you using the Jetson or a camera or other hardware? Are you using YOLO or other algorithm?
Okay, so programs we're using. So actually, because we're in the prototype phase, so ROS is a must. In the robotics world, everybody's now using ROS. Of course, we're using the general libraries, PyTorch. We used to be using bit TensorFlow, but now we're working with PyTorch, and C++, of course, because if you want to make your code production code, then you need to use actually C++. What else?
So you have Abdurrahman. How did you pre-calculated the cost of the project? And are we able for a project like this to find like a pre-trained neural network, like a model already have the ability to recognize the type of plants, for example, and edit it to be dedicated to our goal? Will that reduce the cost of the project, for example?
Okay, so the thing is that there's one thing is that, well, the cost of the project really is not that easy to estimate. So up till now, we've raised around $500,000, and we still need more. But because the thing is, when you are working with hardware, it's much more, let's say, much more expensive than actually just dealing with software. And let's say on our software, like on the software side of things, it's not as expensive and it's more easily plannable. But when it comes to hardware, then you want to get one powerful laser, it would cost you like in the thousands of dollars. But the thing is that, well, I'm more on the technical side, but slowly and surely with good planning, then you can estimate the cost. I mean, of course, you're not going to get the right cost directly from the beginning. Second question was about the data. Yeah, so when it comes to data sets, actually, long time ago when we first started, we did find a couple of weed data sets, well, plant data sets in general. And actually, because we didn't have much money back then, so we used those as reference. And then we tried to run the models we started creating with these data sets. And the thing is that we actually got very promising results with the data set, but the problem is they weren't really tailored for the wheat, for specifically to wheat plants. So they were plants in general, but we wanted to see how this AI would react for when it sees such images. And then once we, let's say, we had the proof of concept that yes, it works, then we had to manually, we outsource our labeling to other companies who labeled for us. And especially because in the literature, you don't really find data sets where they pinpoint the location of the growth centers of the weed. So we had to do these by ourselves. And actually right now, for example, in the Netherlands, we're giving farmers an apparatus to be able for them to automatically, so they would go around their field, they get data for us, and then they get sent to our servers. And then we have a dedicated company that does the labeling for us. And this is how we acquire more and more data sets.
Okay, thank you for that for the question. We still have one last one. Are you using auto-white balancing to detect contrast?
Auto-white balancing so unfortunately, I cannot go into the details of what we're doing, but let's say augmentations related to color we're using, and augmentations related like warping or rotations and these kind of things we're also using. But in detail, what we did, I cannot. But but I'm going to tell you something is that we observed, let's say, 200% improvements comparing data that we didn't apply those kind of augmentations on and data that we did apply these augmentations on. So augmentations are very necessary, especially for this application.
Okay, cool. So
Okay.
yes, like once you can follow them maybe on social media, and once they have the opportunity, you can apply for internship.
If you want, I don't know if my email is shared, but you can send me an email, you can drop me an email or on my LinkedIn, everything, and we can discuss.
Sure. Thank you so much for everyone and for the speakers and for engaging. It was so nice to see like all the engagement to the questions that you're asking, and I hope you benefited. Hopefully we'll see you tomorrow in the panel discussion, and after tomorrow if you're also joining the career fair. Enjoy your night and stay safe. Bye.